Jupiter holds more than twice the mass of all the other planets in our solar system combined. It is a true gas giant, dominating the space beyond the asteroid belt. And it moves fast. A single day on Jupiter lasts barely 10 hours. That rapid spinning causes its equator to bulge outward and its poles to flatten. The famous Great Red Spot you see here is a fierce, continuous storm. It is wider than the Earth and has been violently raging for over 100 years. This massive, chaotic giant exerts an inescapable gravitational pull over the physics of our entire solar system. For decades, the rare Earth hypothesis has suggested our planet is uniquely suited for life, partly because we have a cosmic vacuum cleaner next door. The logic goes that without Jupiter sweeping up dangerous comets and asteroids, Earth would be completely pulverized by space rock. But recent N-body dynamical simulations, which are computer models that calculate the complex gravitational forces between multiple planets, show a different reality. The text of this study concludes that Jupiter's role is far more complicated and that giant planets actually imperil the development of life. If Jupiter suddenly disappeared tomorrow, Earth might actually experience fewer impacts from near-Earth asteroids. If the largest planet in our solar system isn't acting as our shield, we have to ask if its immense gravity is actually aiming these cosmic weapons directly at us. Gravity operates as a chaotic, interconnected web. It doesn't work like a static wall blocking incoming debris. Jupiter exerts a rhythmic gravitational pushing on the asteroid belt, a process known as orbital resonance. This repeated nudging actually forces near-Earth asteroids out of their stable orbits and flings them directly into the inner solar system. To understand this effect, astronomers ran simulations to test variable tuning, asking how the impact rate on Earth would change if we artificially adjusted Jupiter's mass. This chart shows Earth's asteroid collisions relative to Jupiter's mass. Notice the sharp spike between the 0.1 and 0.25 marks. If Jupiter were Saturn-sized, impacts would violently surge. Conversely, at zero mass, the impact rate drops, matching the exact baseline of our current massive Jupiter. When we look at the local asteroid belt, the data shows that Jupiter acts as a profound menace, actively stirring up debris and sending it our way. But the asteroid belt is only one source of cosmic debris. There are also long-period comets, which originate from the Oort Cloud, a vast, distant shell of icy bodies at the very edge of our solar system. When it comes to these specific deep space objects, Jupiter behaves exactly like the massive shield we always assumed it was. Jupiter's immense gravity well successfully intercepts incoming comets, violently ejecting them out into deep space. But in a lower mass scenario, the planet lacks the strength to eject them. The comet remains trapped in a deadly elliptical orbit that repeatedly crosses Earth's path. Jupiter is a complex gravitational puppeteer. It successfully saves us from distant comets, while simultaneously hurling local asteroids directly at our glass house. Beyond violent cosmic impacts, Jupiter exerts a subtle, continuous influence on the physical movement of Earth itself. The gas giant's distant gravitational pull continuously alters the exact oval shape of Earth's orbit, and it slowly shifts our planet's axial tilt over tens of thousands of years. These subtle variations are known as Milankovitch cycles. They directly drive Earth's periodic ice ages and dictate our long-term climate stability. Recent scientific models suggest that if Jupiter's orbit were slightly more oval-shaped, it could push Earth closer to the Sun at key points. This would actually thaw some of our coldest regions and make our planet more habitable. This chart models the lifespan of the solar system based on Jupiter's orbit. The dark vertical bands you see represent regions where altering Jupiter's path triggers rapid, chaotic destabilization, causing the entire planetary system to fall apart. Earth's highly specific, life-sustaining climate is precariously balanced on the exact current geometry of Jupiter's orbit. Looking back 4.5 billion years, the early Earth was a completely dry, barren, and sterile rock. During the chaotic formation of the solar system, Jupiter's early migrations forcefully flung ice-rich asteroids inward toward our newly formed planet. Those ancient impacts delivered the vast majority of the water that eventually pooled to form all of Earth's oceans. Jupiter functions as the violent orchestrator of our existence. It delivered our water, it carefully tunes our climate, and its gravity dictates our survival in a chaotic system.